Hello students, today we are actually solving chemical kinetics CET paper which was held on 27th May. Let us take up one by one. So the first question from chemical kinetics is question number 21. So basically they have given two reactions. So one is A is okay, one second. So it is clearly understood that dA by dt, that is rate law, where K1 concentration of A reactant raised to the power 0 means it is zero order reaction, and B2 products minus dB by dt, K2 and reactant concentration B, which is not raised to any value, means it is understood that it is first order kinetics. And what they are asking, basically they are asking K1 and K2 are expressed in terms of molarity, that is mole inverse, and time second inverse. So now we need to find out what will be the units of K1 and K2. So it is understood that for zero order reaction, we have learned that the K1 units, that is rate constant units, will be as same as units of rate. So which means that option B would be correct. Why? Because here capital M actually represents molarity. So which means that it is here they have given. So molarity is equal to mole decimeter minus 3. Okay, so hence this is the unit for zero order, and time inverse will be units for this first order reaction, that is first order rate constant. Hence option B will be correct. Okay, next question. How do you find the order n of the reaction? By knowing the t half values of the same reaction for two different initial concentrations A1 and A2. So basically we know that the nth order t half formula, so which is proportional to, oh, I'm not able to write, one second students. T1 by 2 is directly proportional to 1 by a n minus 1. So this is the formula, right? So now you need to consider t half for two different initial concentration, that is a1 and a2. So according to that, basically we get t1 by 2 and put the brackets. So this is t half 1 is equal to, so basically 1 by a1 raised to the power n minus 1, and similarly you will also write for t half. So t half, so this is for second concentration, which is equal to 1 by a2 raised to the power n minus 1. Now these two equations, that is this equation and this equation, you have to divide. So this is considered to be equation 1 and this is considered to be equation 2. So divide equation 1 by equation 2. So what do you get basically if you divide equation 1 by equation 2? So then you will get t half t half 1 divided by Here you will write T half, T half 2. Okay, T half 2. So this is 2. So which will be equal to what? Basically, it will become actually A2 by, this is A2 divided by A1 and then brackets, and which will be raised to the power n minus 1. So n minus 1. So this option is actually there in, that is option number 1, that is T half 1 divided by T half 2 is equal to A2 by A1 n minus 1. So hence option A would be correct. Option A would be correct. Okay. Now coming to the next question. So before we start with the next question, let me also erase this. So what is this question? A first order reaction is half completed in 45 minutes. How long does it need for 99.9% of the reaction to be completed? So it is quite simple because we know the formula. So what is the formula? So we know the formula. Formula is nothing but, so T half for a first order reaction, T half for a first order reaction will be will be equal to will be equal to that is 99%. How many times? So 10 T halves will be equal to 99% of first order reaction. So this is a direct formula where, so I will just once again make the formula here. So formula is what? Formula is 10 T halves is basically equal to equal to T 99.9%. So what is T half given? So T half is 45. So 10 T halves will be 450 minutes. So 10, T halves will be 450 minutes. And now this 450 minutes need to be converted into hours. So hence if you convert 450 by 60 minutes, 450 by 60 minutes, you will get the option, that is option D. So which is nothing but 7.5 hours. So 450 by, so you will have to do 450 divided by oh, so 450 by 60 is equal to 7.5 hours, or this option would be correct. Okay. Now the next reaction, that is next question 24. A hypothetical reaction A2 plus B2 is giving rise to 2AB follows the following mechanism. Okay. So here they have given a complex reaction for which the mechanism is being given. So the first step, it must be A2 giving rise to A plus A. So that's a fast, step. A plus B2, which is giving rise to AB plus B, that's a slow step. And after that, once again, it's a fast step. So for any complex reaction, it always becomes important to understand, the slow reaction, because slow step is the rate determining step. So hence, before the slow step, whichever the fast step comes, that becomes important. Now, if you carefully notice these two reactions, let me write the reactions. So now we have the first reaction. So finally, what we need to determine here, so the order of the overall reaction is to be determined. So what is understood? So slow step, we have to write the rate. So if we have to write the rate for the slow step, how do we write? So basically, rate law, according to rate law, if you are writing rate law, so rate is equal to K into concentration of the reactant terms, correct? So in the slow step, who are the reactant terms that you have? So one is A, one is the A, and the second one is A, concentration of reactant term A, concentration of reactant term A, and then we have the other concentration term V2. So this is V2. Okay. Now, if you carefully look into the overall reaction, there is no A term. That is, A is not there. A reactant is not there in the entire reaction. That is either on the reactant sides or on the product side. Of course, A is not there on the reactant side. And also we need to understand that in the first step, that is A2 is giving rise to A and A. As soon as A is formed in the first step, it is getting consumed in the slow step. And hence, A cannot be part of the rate law, and hence A value need to be determined. Concentration of A value need to be determined. How do we determine? Basically means from the fast step, that is before the slow step, wherever the intermediate is formed. So for that step, we basically do K equilibrium. So how do we determine K equilibrium? So K equilibrium is equal to, let me write, for the first step I'm writing actually. So K equilibrium. So K equilibrium, one second. K equilibrium is equal to concentration of A square, that is 2 A's. So A square divided by, we will also write the concentration of the reactant, so which is nothing but A2, concentration of A2. Now from here, you will be able to get the value of A. So how do you get the value of A? So A concentration is equal to K EQ, and put the brackets A2, which will be multiplied. And then since A square was equal to product of K, EQ and A. If you want A, you need to put the root. So hence you can also write instead of root A2 raised to the power 2. So hence, what is our rate law? So rate law is equal to rate law, that is rate is equal to K A2 raised to the power half, and then you have B2. So now what is the overall order of the reaction according to order? So the powers which are raised to the concentration terms in a rate law, the summation of these powers will give rise to the order. So hence the correct option would be 1 plus half, which is equal to 3 by 2. So B option would be correct for 24th question. Then coming to 25th question. So what is this 25th question? So 25th question, once again, they are giving hypothetical equation where A plus B is giving rise to C. It is found that doubling the concentration of A increases the rate by 4 times. And doubling the concentration of B doubles the reaction rate. So what is the overall order of the reaction? So this is basically on the basis of initial rate method. We will be determining what is the order of the reaction. Let us now see how to determine. So I will be doing step by step, so that those who have not learned till now can also easily learn it. Okay, so fine, then let us do systematically and step by step. So according to initial rate method, we are supposed to make the equations, right? So for two different conditions. So now what is the hypothetical equation that is being given here? So the hypothetical equation is A plus B is giving rise to C, right? So now they are telling that A is increased by how much time? 2 times, and hence the rate is also increasing by 4 times. And hence, how do we write basically? So rate is equal to, assume that is rate one. So rate one is equal to what you are doing. Obviously, K will be there. That is rate constant. Concentration is doubled. That is, first initially the concentration is only A, and then concentration of this concentration term will be raised to the power x, correct? So and then concentration of B is there, and whose concentration term raised to y, and this will become equation 1. So what is equation, that is rate 2? So rate 2 is the condition where the concentration of A is doubled. Concentration of A is doubled. So I will write 2A raised to the power x, and B's concentration is kept constant. So B's power raised to y. So which will be equation 2. And if you are increasing the concentration of A by 2 times, the rate is also increasing by 4 times. So hence the rate here will become 4R. So need not to put R2 also here. You can better avoid giving the numbering of R also. So hence this is the second equation. So so what is the third equation? So what is the third equation? So third equation is nothing but you are doubling the concentration of you are doubling the concentration of B. So hence the rate is becoming 2 times is equal to K. Concentration of A is remained same, which is raised to power x, and 2B, which is raised to power y, is equal to third equation. Now solving 1, 2, 3, step by step, we will be able to know the powers, that is x and y. So if you take up the first two equations, divide equation 2 by equation 1, what do you get basically? So if you divide equation 2 by equation 1, so this b term, b raised to the power y and b raised to the power y will get cancelled, and you will get basically 4 is equal to 2 power x, right? So if you solve equation, so what I'm trying to say, you are dividing equation 2, okay, divided by equation 1. So what do you get basically? By, that is b raised to the power y and b raised to the power y will be cancelled, and kk gets cancelled, and basically you will get a value 4 is equal to 2 power x. So hence this 4 you can convert into what? How will you convert 4 into we can also convert into 2 power, that is 2 power 2 is equal to 2 power x, and the x value will become 2. X value will become 2. So similarly we will also do for y. So how do you solve? So you have to take the terms, take the equations where the A values are same, that is concentration of A terms are same. So hence you will take equation 1 and equation 3. So if you divide equation 3 by equation 1, it will become where A raised to the power x, and here A raised to the power x will get cancelled, and remaining will be what? So 2 will be equal to 2 power y. 2 will be equal to 2 power y. So if you write 2 is equal to 2 power y, then y will become 1. So overall order of the reaction will be x plus y. Overall order of the reaction will be x plus y. So hence x is identified to be 2. X is identified to be 2. So 2 plus 1. So how much? 2 plus 1, that is equal to 3. So what is the order of the reaction for this question? So this question is option C would be correct option. Okay. Now similarly, we will also do the 26th question. So what is 26th question basically? So they are telling radioactivity. So whenever we hear, listen to this word radioactivity, it is understood that it undergoes first order kinetics, isn't it? So hence here what they have given and what need to be calculated, we will try to understand. Okay, just a second, I'll be back with the question once I clear all this. Yes. Okay. What they have given? Basically, they have given T half value. Okay. So T half is equal to 10 days. And if 25 mg is left over, okay, what was its original weight 40 days earlier? So we need to actually determine the initial, weight, that is radioactive isotope. Okay, because they are telling after 10 days they are saying that there is 125 mg is remaining, radioactive isotope that is remaining is 125 mg. Then before 40 days, how much was its initial weight? Okay, so we have a formula here. Once again, let us apply the formula. So what is the formula basically? So formula is very simple. So in terms of concentration, that is concentration of A at time t is equal to concentration of A naught, that is initial concentration, which is multiplied by 1 by 2, which is once again taken as the power n. Okay, so here we will write to the power n. Correct. So this is the formula. Basically, how do you determine n value? So how do you determine n value? Huh. How do you determine n value? So n value will be the total time divided by t half. T half. This is the formula. So what is the total time they have given? So they have given the total time to be 40 minutes, sorry, 40 days divided by T half is equal to 10 days. So now n value you are determining it to be 4. So substituting value of n and value of AT, you will be rewriting the expression. How do you rewrite? So with the values, so here you will write AT, that is after 10 days, 125 mg is left, which is equal to A naught you are supposed to calculate. So A naught concentration into 1 by 2, which is raised to the power 4. So which is raised to the power 4 means how much it will come? So 1 A naught is equal to 125 into 16, which is nothing but 2000 mg. So when you convert 2000 mg into grams, obviously it will become 2 grams, because 2000 by 1000 you will do, so that you will get the answer to be 2 grams. So answer A is correct. Okay, option A is correct for 26th question. Okay, now coming to 27th problem. So it is the question based on the first order kinetics. Okay, so the concentration of a reactant X decreases from 0.1 molar to 0.005 molar in 40 minutes. If the reaction follows first order kinetics, the rate of the reaction when concentration of X is 0.01 molar will be. Okay. Now let us solve this question. So it is just, based on the simple integrated first order, equation, which is nothing but K is equal to 2.303 log A naught by A, correct? So we will apply the same formula and then we will try to get the value of K. And once K is determined, it is quite easy to determine the rate, because we know what is rate formula. So what is the formula of a rate? So formula of a rate is nothing but, okay, fine. Before that, let me write the integral equation. So K is equal to 2.303 divided by T log A by, that is A naught by A. Okay, A is nothing but the concentration at time t. Concentration at time t. Now, what is the hypothetical equation that they have given? What is the hypothetical equation? So they have given X is giving rise to products. X is giving rise to products. Now, basically, any hypothetical equation that we take, so we will assume when T is equal to 0, concentration of X will be A only. Okay, which means that there is no formation of products. A will be initial concentration A naught. And when T is equal to, here in this case, they have given 40 minutes. So hence it will become A minus X, because there will be formation of X moles, that is X moles of P, and hence there will be A minus X concentrations left at time t is equal to 40 minutes, right? So here in this question, they have directly given that x decreases from 0.1 molarity to 0.005 molarity, which means that A and A minus X values are being given directly, and hence just substitution and finding the value of K. So how do you find the value of K? So K is equal to 2.303 divided, that is divided by 40, then log, what is the value? What is the value? It is 0.1 divided by 0.005. Okay, so 2.303 divided by 40 value would be 0.0575. Okay, into this log, if you divide 0.1 divided by 0.005 value, it will become log 20. So now we all of us know that how to convert log 20 into the simpler forms so that we can easily write the value, predict the value. So this can be written as log 10 into 2. Okay, now this is actually in the form of log A into log B. So log A into log B is equal to log A plus log B, correct? So hence we will write in that format. So where you will get here 0.0575 into log 10 is equal to 1. So I'm writing directly 1 plus log 2 value is how much? Log 2 value is how much? 0.3010. Okay. Now the product of these two will be giving the final value, which is equal to 7.49 into 10 power minus 4. Okay, concentration, right? So mole per liter or a molarity, mole per liter or a molarity. And what is the value that is being given here? So here 7.49 is not there in option A, option B, option C. So hence none of the above is the correct option. Okay, now coming to the 28th question, chemical reactions with very high activation energy, very high activation energy values are generally. So this concept is completely based on effect of temperature and activation energy. So here it is quite simple to understand. We know that activation energy and the concept of fast reactions and slow reactions is completely based on effective collision, fraction of molecules having effective collision, correct? So now when activation energy is, okay, let me write. We have two conditions. You need not to remember both the conditions, either of which you can remember, so that automatically you will be able to remember the other one, right? So if activation energy is low, okay, but here they have asked for high, right? So I will do it for high only so that you can remember for the other one easily. Okay, so now what is it? Basically, they are telling that activation energy is very high. Activation energy is very high. If activation energy is very high, there is something called F, okay, frequency factor. So what is this? Basically it involves two things. F involves two things. Which are the two things? Which is responsible for fraction of molecules having effective collisions, right? So F will be involving two things. Which are the two things? One is the minimum required energy, okay, and the second one is what? That is proper collisions. That is proper collision, which is also referred to as steric factor, that is rho, right? So here the energy component is involved, and here the steric factor rho is involved, right? So if EA is very high, it is assumed that F will be very less. F will be very less. If F will be very less, which what is understood? Basically, the number of effective collisions taking place is also less, and hence the reaction will become very, very slow. The reaction will become very, very slow, and hence option B will be correct. Okay, so very high activation energy means then the reaction must be very slow. Okay, hope you understood. Now the next question we have is the 29th question. Once again, it's a very direct question. Even in the class I had told you to remember few, what do you say, reactions as examples for zero order, first order, as well as second order reaction, right? So now take up the first example where H2 is reacting with Br2 to form 2HBr, right? So basically these reactions, that is reaction with halogens, will take place either thermally or photochemically. These reactions need to undergo either under the thermal conditions or under the photochemical conditions. Basically, we have given or taken the examples of photochemical reactions under the heading of zero order reaction, and hence option A and option C can be considered to be the zero order reactions. Okay. Then the second option, that is NH4NO3, which is undergoing decomposition to give N2 and 3 moles of water. This actually comes under the category of the first order reaction. Okay. Now, hence, we understood that option D only will be the correct, option for this question, where they are asking for the second order reaction, right? So, which one of the following will be a second order reaction now? This one. So, I told you also in the class that when esters, because here we have taken, methyl acetate or ethyl acetate, any ester, when it is subjected to sodium hydroxide, that is alkali hydrolysis, the process is called saponification. Saponification is an example of second order reaction. In the place of sodium hydroxide, if there is water molecule and on the arrow mark acid is written, then that will be an example of first order reaction. But here this is a saponification, alkali hydrolysis of ester, and hence this is a second order reaction. So option D would be correct. Okay. Now the last question. So what is being asked, what is given actually? Okay, fine. Let us go through. So 1 liter of 2 molar, okay, that is acetic acid, is mixed with 1 liter of 3 molar ethanol to form an ester. The rate of the reaction with respect to the initial rate when each concentration is diluted with an equal volume of water will be. So it is once again based on the initial rate method that we are going to determine the rate with respect to the first reaction, right? So rate 2 we are going to explain in terms of rate 1, correct? So that is what they are asking. So what they have taken, basically, let us write two rates with respect to the first concentrations and with respect to uh, the said the difference in the concentration. What they are doing, basically, the rate of the reaction with respect to the initial rate when each solution is diluted. So each solution is diluted means what will happen to the concentration? So concentration also will be reduced. That too, how they are diluting? Each solution is diluted with an equal volume of water. So if 1 liter of water is being added to prepare 2 molar, now to the same thing 1 more liter is added means what will happen to the concentration, that is 2m? It will become half, correct? So now half of which concentrations are mixed, then what will be the rate of the reaction is what is being asked in the question. Okay, now let us write the first rate. Okay, so what is the first rate? So first rate, that is R is equal to what is given, basically. So 2 molar here, since they have clearly mentioned the concentrations, need not to write in terms of acetic acid and ethanol. So directly you can write the concentration values of acetic acid and ethanol. So here it is 2 moles, and which is also mixed with 3 moles. Okay, so hence in the first case it is becoming 6. Okay, product of 2 and 3 is becoming 6K. Okay, K also I will write. And second case, what they are doing, basically, so the concentration, that is dilution, is happening, and hence 2 by 2, because the concentration is reducing to half, and hence it becomes 2 by 2 into 3 by 2. Why 3 by 2? Because the 3 molar concentration of ethanol is being reduced to now half, right? And hence it will become 3 by 2. So now the product of these two will become equal to 1 by 5. 1 by 5, correct? 1 by 5K. Now what they have asked, they have asked the rate of the reaction. Where is it? Yeah, the rate of the reaction with respect to the initial rate when each solution is diluted. Each solution is diluted with an equal volume of water. So hence what do you do? So 1.5, 1 1.5 divided by 6, if you do, you will be getting a value of 0.25 times. So which option will be correct for you now? Now option A would be correct, which is nothing but 0.25. Okay, hope you understood all these questions. All these questions are quite simple, and if you have any doubts, you can ask me during our class hours. Okay, thank you, students.